this whole thing is really a sort of trust issue of just developers kind of like misplacing their trust into TypeScript as a security tool, which is something that I would like the developers would stray away from. Like three things are important, for you as a dev in security. One is do not trust user input. Two, do not trust user input. Three, do not trust user input.
Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Eric Onerheim. Together, we're the two TypeScript fools. Welcome to the show.
Hello, welcome to TypeScript FM. Today, we have Liran on to talk about security and TypeScript.
Hey, everyone.
How's it going?
All good.
Awesome. Liran, do you want to give like a short introduction to yourself just in case listeners don't know you and tell us what you've been up to?
Yes, thank you for inviting me to speak about this because talking to developers about security is kind of like my passion. So this is where I'm at. I'm Liran. I'm officially a developer advocate at Snake, so this is kind of like what I like doing. I guess, unofficially or in some ways during this role. I'm also doing a bunch of things like security research, like finding vulnerabilities in different packages and libraries and stuff like that. If you did like an NPM audit or a sneak test or something like that, and you saw like 17,000 vulnerabilities just added. Maybe one of those was mine, kind of like reporting it or maybe fixing it. So this is kind of like the ecosystem. This is what I do. I do like a bunch of those kind of things around different communities. So the Node projects and OpenSSF and OWASP and stuff like that. And I got down to figure out this whole thing called TypeScript security, which is why we're here.
You know, you are prolific. I was like digging through, like looking for questions to ask you, but you are so busy. Like, how do you do it? Like, you've got so much going on.
Less sleep. Good priorities, less sleep.
Wow. Like, I feel like I'm barely hanging on. So, and I am not as busy as you are.
Well, it's been fun.
I like your Yoda hat. Do you have a little story about why you have that in your avatar?
I don't know. I feel Star Wars is a good enough story to go there. There's like good philosophy around that. So I'm happy to kind of like convey that and run through that.
Love it. That's funny because I'm playing a Star Wars video game right now, so it's very top of mind for me.
That's cool.
So I initially saw you because you gave a talk about TypeScript security. And I think the number one thing that came to my mind as soon as I saw that was, what is special about TypeScript security versus just JavaScript security? So I don't know if that is a good place to start. I think for the listeners wondering, what is this all about?
Yeah, I think around this is like a really good start because that is where I think the fallacy kind of like exists around TypeScript security. And this is like literally how I titled kind of like my presentation slides around this, because I feel this is where that's like a pit that's easy for devs to like just fall into this trap. And to kind of like put that into perspective, like more practically, the moment that you like type things, you get that sense of like, yeah, it's a string, it's an object, it's an array, it's some interface that I define how it is. And I think that's especially true if you're coming from like strongly typed languages. Like if you're coming to TypeScript from like a background of doing Java or something like that, then you automatically kind of like project that trust onto what TypeScript does. And the amount of devs that I talk to like do not realize that it's just like a dev time versus not being a runtime is like a complete news break that you've like just told them. And this is like so funny. So this is how everything starts and unfolds and unpacks from this point on.
Yeah, no, totally. And I think that's even to this day, I feel like, as much as we repeat that the types evaporate and they're completely compile time, completely dev time, I think that is like one of the most common misconceptions with TypeScript is like, well, is it actually enforcing these types? Well, not really. It's not doing anything. It's doing what you said it is. So it's only as good as your mental model is.
Yeah. And just think like how even more involved that assumption that developers have when it's not like a vanilla TypeScript project. So what I mean by that is, imagine you're using something like Angular or Nest.js, like the Node.js backend framework, where there exist like so many abstractions. And potentially there's like, an annotation on top of, some function or some type definition. And you automatically infer, oh, okay, so that's supposed to be like a string type. It can't be anything else. But like, no, that's like just something that they like abstract the TypeScript stuff behind the scenes. That's not like runtime validation. I get that you understand that you got that out of like maybe just looking at it, but you just like projected your kind of like interpretation of what it is. And like as developer, maybe you didn't go and read, the docs or was like well trained on this to understand that it doesn't do what you expect it does. And a lot just get lost into that abstraction model.
What's like a really specific example maybe that you can give? You're talking about like, oh, maybe you're typing it as a string, but like,
Yes.
where can that go wrong?
100%. So let's talk practically, which I like. I like that you've put me in line here, Eric. So my prime example is the following. Imagine you build an Express kind of application with TypeScript, which is like my kind of like, stock, because everyone probably are aware with those two. Imagine you have this like query strings for a filter or some user ID or I don't know, something like that. And it's in the URL, you want to type it. On the request level on Express, you'd probably do, query string are coming in. I want to extract, that element in the query string. So you do const name equals request dot body, or in the query string dot query dot something. And internally, like in your code, what you do is you type it out, right? Like you say const name, and then like the colon is string, or maybe it's something else. At that point, like what you're doing is you are telling TypeScript that this should be a string, and that's how you continue kind of like acting towards this type throughout, and the compiler is happy and so on. But at runtime, what would happen is potentially someone can lean in and say, you know what, name is not going to be a string, and automatically developers are like, wait, what? Like that's a core string. That's literally a string. And it's like, no, of course not, because you can give it like this bracket notation and say, name with two brackets notation, empty brackets notation equals, Liran, and literally the end, ampersand character name, get notation again. So again, an array equals Eric and so on. Now you can like have to ask yourself, and this is kind of like what I do in those like presentations when I'm like on stage and I'm going like, all right, now look at this code and tell me, what do you think it does when you extract like the name as a string onto in the Express when someone sends in something that's not a string. And you could see like you can see the the looks of people, because they're like trying to think out like, wait, what's gonna happen? It depends what it does. Like what other things do I have there? And I think that's kind of like really nailing it, because they don't know. And honestly, there's no like one single answer, because it really depends. I don't know. It depends what middle words you had in Express before that. It depends what you had after that. It depends if you're using Express or Fastify. It depends like on so many things. And there's like no one good answer that will tell you what it is, because it can be interpreted in many ways. But this is essentially the point. You would not know to say what it is until you looked at the code, until you examined it, and you know exactly what middle words you have, what goes on with a request, if you have like a schema before that or after that or whatever. And that kind of is the point. Now, why it matters is a whole different point. It matters that you're not really typing it and like you're trusting the TypeScript types in code versus what goes in runtime. Because if you don't have that, then that's a security issue. And it's not even a schema validation security issue. It's more like it's a security issue because your server, you basically have like an undefined behavior right now, because Express, you have no idea how it will get interpreted. And I show this other code snippet example where I like code like a simple, React server component where I get, some like a name, and then I want to respond back with like an HTML kind of presentation of the response. So kind of like I'm kind of like rendering it on the backend. And my code also includes like an XSS, because I don't want to just render, whatever you give me, right? Like a name now equals an image tag, you start off with like the, the Angular brackets and like an image tag, and source equals blah, 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 and or on error alert, blah, blah, blah. So an XSS coming in. So maybe you use something like, name that includes and make sure that it doesn't include any of the other things like, what you would do in HTML entity encoding. And the thing is, specifically, that's a really good example because if an array falls into as part of the code flow from that name string into that function, specifically name that include, you are basically using an array instead of a string. And that's a game over because that function is never going to turn out to be like a sanitization function for you. It's not even going to be like an exception throw that you would know how to handle or know that it happened. It's literally going to return nothing and an XSS flows in. This whole thing is really a sort of trust issue of just developers kind of like misplacing their trust into TypeScript as a security tool, which is something that I would like the developers would stray away from. Like TypeScript is good. I'm not here to say TypeScript is bad. No, it's good. It's great. Use it. I don't know, worship it if you want to. I will not tell you not to do that. That's okay. I don't know if that's what you want to do, but please do not treat it as a security boundary or a security tool or call it static security because it's not that. Please don't do it.
Yeah, it only protects you from yourself, and really you shouldn't be trusting types from the user. We're always hearing don't trust user input, but in this case it's don't trust types that come from a user. Don't assume that they gave you the type that you thought you got.
100%.
So let's take that example, that really simple example of const name : string equals request dot query dot name.
Yeah.
Is it as simple as saying if type of name equals string, I'm done? That's okay. If it's true, then I'm okay. Or is there more to the story for how to sort of address this kind of request input validation?
So I think it's a good question. I think just to prelude that, we'll say that what we described before as the attacker sending you name like an array bracket thing versus name equals just a string is not something that we made up. It's literally called HTTP parameter pollution. The idea is that there are attacks where the hackers or adversarials are trying to fuzzy test and basically send you a bunch of different strings and types and whatever just to see if they can trigger some kind of undefined behavior, and then they go from there. So my example that we took there of sending you an array instead of a string was literally the case of CVE of a vulnerability that was reported to a big company and landed the attacker who found it some $10,000 because they found it. They traced it back in the company to an open source component that they used that's called LinkedIn, that's JS LinkedIn, which is a template engine for Express. This is about a decade ago. So this whole thing is a real example, and this is a decade old real security concern.
Wow. Yeah. So in that case, would that type of have helped there, or would it not have? I guess it depends on how you're interpreting the string later on, but so I guess does things like Zod and archetype help you here, and where do those Zod and archetype kind of fail to help you?
Right. So the type of is a suggested a recommended type narrowing from the TypeScript team as well. It works. That's runtime because that does not get stripped. That's not something the compiler turns away. That's actually not even TypeScript. That's literally JavaScript. So that works. If you want to do that, that's fine. I guess that's my only intuition on that is if you start doing type of after every
everything, everywhere.
Everything, yeah, then potentially you abuse it once. Secondly, maybe it becomes some kind of culture where people start using it for no reason and code becomes unmaintainable. The people that stop losing why the idea of why they even started doing that. Unmaintainable, you start asking yourself, so why am I using TypeScript if we're using type of all the time? And I don't know, I feel it's the sort of the type of stuff or the sort of controls you want to add, but not everywhere. You want want to be mindful of what makes sense to add that. And this is, I think, also a good segue because it brings us into Zod, where you would say, yeah, we probably need to harden the request payload itself. So we would be able to put what we call schema around this payload and say, yeah, a core string needs to be, a string, but we do that via schema for the request itself and so on. And that's also good practice because you could now reuse the schema for inferring TypeScript types, which is one thing, which is nice. But also imagine that you have the same kind of object repeated in different inputs. So imagine a more kind of feature rich, more enterprisey kind of application where the same input may come from like a query string, but also maybe another input point to the application is like a message bus, and you have like the exact, same schema. So instead of like repeating yourself, kind of want to reuse it. So that makes sense. But there's also some gotchas there that we have to be very, very conscious of.
Yeah. And it's kind of making me like, oh, anything that comes over the network, we probably should have, maybe we type it as unknown, not as like any, or we type it as unknown. So it forces you at that boundary to be like, okay, we need to prove the type before we use it.
Because you mean like unknown, like as like a coding standard for the team to then like figure it out what it should be, or?
Yeah, I'm just throwing it out. Like maybe like any place where like types can come over the network, we just say, we're not even going to guess the type until we run it through Zod. Like we'll just type it as the TypeScript unknown type, and then you say, okay, well, we'll run this through Zod first, and then okay, now we've got a type that we validated against a schema.
Okay, I mean, I can see that happens as well. And I guess at that point, you might want to like be curious of like what could go wrong with Zod as well, right? Because that's not
right.
perfect.
Yeah. If we're like hanging our hopes and dreams on Zod, like what can go wrong there?
All right, so I was looking into that, and then I found like two things that kind of like bothered me and could be indeed, end up as a security vulnerability for sure. But like it's not a security vulnerability within Zod itself, just as TypeScript is not a security issue as of itself. It's just like whatever you put trust in it.
Mm-hmm.
And so the first fallacy, I will call it, the first fallacy with Zod is while you can type things, sometimes those things could take a different shape that you did not foresee. Here is where I'm going at.
Mm-hmm.
There is this exotic kind of vulnerability in JavaScript called prototype pollution. You might have seen that. Yeah, have you got that one ever?
I've definitely heard of prototype pollution, and maybe even participated in the old days when we were like monkey patching stuff on browsers where you just throw stuff on the prototype. Yeah.
Yep. Yeah. Do you want to explain what is prototype pollution?
At the basics of JavaScript, there's like a whole prototypical inheritance where to give, again, practical examples and not, speak high level here, if you have like a route on the backend that's like if request.user that is admin, and then you go in and you do something amazing. What happens as long as you've put, the user on the request object has an isAdmin property equals true, that's great. Or I mean false, that's also great. But what happens if there's no isAdmin on the object? So JavaScript, the thing, goes in and looks at the request object because there's nothing on the user object. And then it looks on the prototype of that. So this is kind of like the, I don't want to call it pointer kind of way of like trying to look back onto different, like bubbling up the way that you look onto objects. But this is kind of like the way it is. And if you think so, okay, so this is just like the prototypical inheritance. Now, prototype pollution is what happens if I, in some way, as an attacker or user that interacts with the system, am able to then create some kind of interaction with the system that would now override that prototype. So object.proto or the proto of other objects would actually point to whatever I wanted it to be and not to null or the object prototype, which is what you get at the end of that, prototypical inheritance chain if you bubble up enough to the top. And if you do that, then it means that anytime that you do not have an object property defined, I can override it. And that's kind of like what I want to do as an attacker. So here's the Zod case. So imagine that you have a case where I'm going to use like an example where you have like 3 different string types that you defined. So imagine a notification systems and it has something like notification type and notification modes and I don't know, notification value for it. And these are like 3 different strings and, notification type is going to be like an email or a digest and, mode or a repeat is like a daily versus something else. And they're all like strongly typed via Zod and TypeScript as strings. And the way to kind of like abuse or like use them is like, you could think of like 2 ways where you could potentially like primarily do potentially insecure code with those strings. One is you do like an object sync kind of interpretation. So imagine that you do like the object and like user something or notification system, and then you use like brackets, put the variable inside it so it's dynamically interpreted, and then like imagine a 2-dimensional array, so another brackets and then another like the mode of it equals the value of it, and all of those 3 parts to how you set maybe the notification from the user are all dynamically interpreted from those variables. And at that point, you basically, you kind of like need those three parts to really control and create a prototype pollution. When you've done that, you can imagine that I can now use magic keywords from JavaScript and set those three parts. So one is set, underscore underscore proto underscore underscore, which is the proto magic. And then the object that it would point to. So now you can call it is admin. And that is what I would want to control with the second, parameter equals, and then the value that is admin gets. And that gets interpreted into the notification system as if you've dynamically, like if you try to like imagine what it would be, you've like now dynamically went into the proto, set a property on it with a value. And so to kind of like completely unpack this, if I am able now to send you a request that has those three values into those three variables inside the application that interprets them like that, and like this is the coding like style that they do, like directly interpret variables dynamically like this, then you get a prototype pollution. And that completely surpasses TypeScript and Zod because they are strings, but they're just not good strings, or not the strings that you were thinking to protect against. And like no one thinks about like, yeah, like maybe I'll set it to proto or email or whatever. Like if it's just, doesn't exist and it doesn't exist and some service behind the system, says, I don't know, 500, whatever, I don't know, 400. But for at that point, but the moment that they already in the system and you've set them into that variable, you have now poisoned the system. So the next request that you will do, if request user is admin, you are actually gonna get, true, even if that admin property doesn't exist, because it goes up to the prototype chain and finds it.
You might even need to restart the server, right? Because now, like maybe you've polluted like a prototype, like a global prototype that is now.
Yeah, you shouldn't restart the server. You actually want to. The idea is that this is like a two-step thing. You want to poison the system first, in a sense, and then the next request is going to get poisoned. Like if we're talking about a node single-threaded. But if you restart the system, if it's like, I don't know, it's a different request, or you got like a different server at the end of the day, then that's not the one that's polluted at that point.
So I'm wondering if the way to mitigate this is to then not only say it's a string, but it is a set of these allowable strings. Is that the way to mitigate this?
Yes, 100%. So it means you have to be much more, like give it a closed list. You have to be much more thoughtful of those types. So you have to give it, a closed list, a dictionary lookup kind of thing that maps into it. But it has to be something that you indeed control as like an allow list. And I think if you think about it more, it's not just... I mentioned before, like the way that you could incur a prototype pollution vulnerability in the code is not just dynamically interpreting like two-dimensional array via parameters like this, what's called an object sync, but also if you do like a JSON merge in an insecure way, you would get the exact same thing because they all do recursive merge. And what they do is they look at the object and they go and say, okay, put that key and value into the object, and they recursively go through it. And what happens is when they get an underscore underscore proto, they actually go to that object, like they immediately go outside of what you expect or you thought of as a developer, and actually go to the object that the underscore proto like points to. And that has been actually the more popular approach of people being like developers and maintainers being vulnerable to prototype pollution. And you can see that like so in so many ways. There's like so many Lodash and imagine all those like utility libraries that are like allowing you to set, you give it like an XPath of like an object kind of coordinates, and it goes and sets it like dynamically however paths deep into the object, because they do this recursive merge and they do not look for underscore proto as something that could potentially create prototype pollution. So if you do that, game over. I have an AI and LLM kind of like angle to it as well, where I was like, I wonder what the LLM will spit out right now, because it's like trained on so much insecure code examples. I was like starting a to-do, like do Copilot in the idea. I was like, to-do, you now need to do a recursive merge of this JSON into this target from this source. I was like, function, JSON merge, target source, opening the brackets for the function definition, and then voila. Copilot completes a vulnerable, insecure kind of like JSON recursive merge, which, yeah, if you're not aware of this at all, and like, no one likes or understands recursiveness kind of thing, you're not even going to dwell into this. And so magically, you're getting a vulnerability there.
Is like object spread the ... operator, is this vulnerable to the Dunder proto on Dunder?
No. What is...
That's not.
No, that's not. Okay.
Okay. Well, that makes me feel a little better.
I'm really glad that you mentioned and gave the example of like Lodash utilities for like merging, because the immediate thought was I'm using Redux for my state management, and I actually do use like the merge utility, or I think they even have a deep merge utility that does recursive merging, because spreading can be really annoying and it can be easier just to do a merge because it's a simpler operation. But now I'm thinking, I wonder if I'm merging some user input, if they're able to add properties onto that type, I could be
Right.
opening myself up to this type of prototype pollution vulnerability. So I think hopefully that's helpful for listeners of like, this is a concrete example of like, if you're doing Redux state management and you're using Lodash utilities, you might want to be thinking about this.
Indeed. And I think we haven't like talked about like the impact of what would happen if you have a prototype pollution vulnerability. Maybe some people are like wondering.
Yeah. How bad is it?
So it's I mean it's as bad as like RCE, which is like remote code execution. So essentially at that point, like the badness level is like a 10-point critical, because it's everything from like denial of service. Like I can overwrite a toString, for example. So boom, like no toString, no exceptions. Or I can literally like do like require child process or whatever, like do dynamic, module loading and stuff like that. And then, OS commands or whatever. So really the impact of prototype pollution is as much as you can, like, as the attacker would want to put into it. I love it how developers are sometimes telling me, yeah, but it's so hard to make it happen. And so I was, and then I go off and like I pull in like, hey, here's a story of like Grafana and Kibana and a bunch of like different tools that were exploited. There's like a whole story of like how they were exploited through prototype pollution out of, someone was able to like spoof off in a way, like a node process with controlling the environment variables, because he was able to like, or they were able to like control the prototype. So it's such a funny, good story. There's like a bunch of those. So every time I come across this, I'm like sharing them, because like everyone are like, yeah, it's such an exotic vulnerability. It happens to Lodash and Jest and whatever, but like never to me. So maybe not.
Yeah, I think now, like, I'm just gonna have like my spidey sense is gonna activate anytime I'm like constructing an object manually, like where I'm indexing it at properties. It's just like you should instantly be like, there should be an electric shock through the keyboard. Be like, no, don't do that. Like, just don't do that.
If only you had an FCP server for shocking you when
Yeah, I mean, I probably could. We could rig something up.
rig something up. I like that.
Anytime you type Control-C, Control-V, electric shock. No.
That actually brings up a good question, which is, do you know of any, like, are there safe utility functions that do this check for you, or is there just, you should just avoid it? Or how do you safely index and create a dynamic object then, if this is going to be a vulnerability?
Yes. So there's like a whole playbook of what you should be doing. Like two obvious ones are, do not like interpret like variables dynamically like that, or at least like, put it like you were suggesting before, like, work with an allow list, but that's one. The other one is literally just do not do an insecure like deep JSON merge. There's a way to do it securely. So that's what all these, deep merge and whatever utilities did. And this goes back to like Happy JS framework, where it's vulnerable to that. And then they like added some dependency that was doing it in a more safe way. I think there's like JSON safe something. And Matteo from like Fastify did the same thing. They have like their own version of doing like a fast JSON merge that is secure. Those are like two obvious ones. There are other ways, or less kind of like good fast ways. The one of them is literally just freeze the object. So if you can, that's not an easy thing, but if you can and it doesn't break your app, because like you said, like, back in the day we used to like, change the prototype for like different stuff, arrays or whatever we wanted to put on it, because of like, the early days of JavaScript and whatever. But potentially if it doesn't break your app, you could freeze the object is another way to look at it.
Yeah, I've definitely seen that in like a lot of state management, but mostly I think from the lens of keeping you from mutating your state accidentally. Yeah, I can definitely see the object.freeze being like a super useful security feature potentially to keep code from tampering with it.
That also brings to mind like immutable JS or other data structures that help with immutability, so that you're not mutating those original objects.
Yeah, totally. Yep. I definitely have used Immer. I think Immer in the past, not in a security context, but in a like, don't mess with this object, please.
Yep. those are familiar names. There's like so many prototype evolution vulnerabilities because I think the moment that like security researchers have seen that this is something that they could like report on and actually cause, a lot of headache, there's like been a barrage of like security researchers looking into that, like inspecting libraries for that. And there's like so many of those like deep merge kind of like libraries into NPM. So there's like a lot of those happening in the wild.
Yeah, I'm glad you brought that up because like that is not a thing I knew to be afraid of before, is like merge libraries or merging JSON. So now I'm going to be like hyper aware of that in my code. Do you have like, like as a security engineer, you've probably seen it like most all of the bad things a dev can do. Like what are the best things that devs can like do to help their app security, especially in the JavaScript world?
Whenever I give a talk or talk to developers, whatever, I say, three things are important, for you as a dev in security. One is do not trust user input. Two, do not trust user input. Three, do not trust user input. That's the moment I've kind of like solidified that thing into someone's brain. I think they code review it differently. They think immediately on, hey, is this user input? And they're like, they're like reviewing some file upload and they're like, oh yeah, maybe the MIME type is user input. Maybe the file name is user input. A lot of things can be user input. So like they start asking the question, which is what you want. And yeah, it's not like, it's not everything is user input in security, but like it's a very good way to kind of like get them to think of this, because basically injection attacks, they take so many different shapes and forms. The simple example is concatenating user input with what you intended. So SQL injection, you concatenate, input of users from what you intended to be a query. OS command injection, the same thing. XSS is JavaScript, the same thing. They are all injection at the core, and they have been like the most massive security issues to handle. And they're like so easy to fix if you just take the right security controls and stuff like that. Yeah, there's like so many other things I think that, you could take as a best practice, but I think critically what is user input and what you should do against it to put like the proper security controls for it.
Yeah, for sure. That I think is like a huge takeaway. And now I'm like thinking, okay, well now don't trust user types. Like the types could be lying to you. Don't trust the types. Verify the types.
I mean, with Zod, there's like the rabbit hole goes further, because there was another thing that I was looking into, and that's like it's beyond prototype evolution. It's imagine that you're getting an object from the user and like literally like the user profile or something like that, and you take that, you run it through like Zod.saveparse or something like that. Everything is satisfying the schema, so you take that object and you push it into like the database, like user.save, and put the model there. And I don't know if people understand this, but if you do that, and what happens is I can actually control more fields on that object. So saveparse just says my, Liran's age equals, 40 is fine because age is part of the schema. But if I go and add to that request as a payload, as an attacker, like Liran is admin equals true, that doesn't like trigger any issues with the save parse from Zod. And so because it's an additional one that's not on the schema, so you take that and you save it as is on the model. And if that's something like, I don't know, like some, document store based like a MongoDB or whatever, and there's no other validations or schemas going around, you've basically saved that and you have now tainted data onto the model, which is a very, very common use case for ORMs when you just paste over like a model.
Yes. That's a really good call out. This is actually a great segue probably into how we should close out the episode, which is AI is on the rise. People are using LLMs to now create code. One specific example I have dealt with creating agents. I'm using a TypeScript library, and they use Zod to do the input validation. Well, what's funny is that by default, it actually didn't validate the inputs. So I was running into a case where I was asking the agent to do something, and it passed the absolute wrong value to the function, and it still got executed, and it created a injection attack, but like in Slack. So it like injected stuff into the Slack message. And with Slack, you can do different annotations and markdown the Slack syntax to create links and stuff like that. And so it created a bunch of random links of like buttons. And so when I clicked the button, it didn't do the right thing. And I could see that being a security vulnerability.
Well, yeah, you could move laterally in a company's network.
Exactly. So I'm just curious, what are your thoughts on like how these LLMs will play with creating and maybe solving security challenges?
Okay, let's unpack. Let's sit back and unpack this. Look, I think we see that LLMs are definitely like becoming better and better at producing code. Hopefully things get better, but not today. Today, if you get an LLM to generate code, and especially if you can like vibe code it in terms of like you do not, and I don't mean that in a bad way. I mean that in like if you're like giving it not enough context, you're not saying it should be secure, blah blah blah, then that by default like is a bad thing. And I have like a good experiment where I take like ChatGPT, which uses the default like I don't know GPT-4 or something like that, and I tell it implement a post endpoint for file uploads for Fastify. It goes off and it implements it, and it's functionally well. So you can imagine someone just taking this and like literally copy pasting it to the code. It's like just an endpoint. They don't have to understand like file MIME types and multi-port uploads or whatever. It's easy to just do it. But the way that it takes the file and concatenates it with the uploads directory, again, insecurely, concatenation, remember, you get the path traversal vulnerability. So anyone can say, my file name is actually not Liran or Eric.jpg, but, .. and you can imagine what goes there, and you have a file arbitrary upload and blah, blah, blah goes well. So this is with recent models. And we've also done the other thing where we benchmark models and AI apps, so like different like Cloud Code and the Cursor and all of those, and we say, create this note-taking app. It has to be 100% secure. If not, I'll be fired. Take this seriously. Like we literally put the same prompt all the time, so we can like reproduce we know that we're reproducing the exact same behavior, at least on our end. We try it with like different models all the time. My story on that, you get like different results with all of them and the different apps and whatever. So there's a video that captures all of that process every time on the Snake YouTube channel thing. But my point is, we did that with Claude 3.7. Remember when that popped up? That was like, for us, it's like ages ago, but I think literally it's like 2 months ago or something.
Yep.
But when it did, we were like, yeah, you know what? Let's give it a prompt, try it out. Because it's like such an easy, long-hanging fruit for us to just test it out. And I mean, Claude is just amazing at code. But when we went through that 3.7 and gave it that, the code that it created was super well. It was like, you had like, no SQL injections not happening because it had like a good sanitizer. It had rate limiting. It had like a no XSS express middleware thing. It seemed to do really well. And it had schema validation like all over the place. It had it on the route. It had it on the model level for Mongoose. It had it at like different places. So I'm reading the code. I'm reading the code. I'm like, GitHub, open this folder, watch this, because like my friend like uploaded it to GitHub so I can see it. And I'm like looking at everything. And then it hit me. I'm checking it out, and I'm seeing that there's a regex to validate the email for when you want to like authenticate as a user. And I'm like, okay, this is fun. Let's look at this regex. And my mind, like Eric said before, and like, being critical with like, user input and stuff like that, my mind immediately goes to like REDOS, which is regular expression denial of service. So I'm reading this regex for an email, which technically works, but it is a bad regex. It has this catastrophic backtracking trait that if I give you an email in a specific format, it goes through all the other validations because it is an okay format as an email, right? But the strings that it has and the validation that happens at that Mongoose level for the email, even though like someone like a developer might say, amazing, the model went the extra length and added like, validation on the model. Great, but this is not the good regex to use, and who knows how regexes work. And I was able to like trigger that, and we have a demo where I show that there's like the CPU goes to 100%. Node.js doesn't get any requests anymore the moment that you try to register with that kind of email. So it's a fun one, and it goes to show this was like 3.7 Claude Sonnet when it was just out. So my point is, there are a lot of issues around AI and LLMs. Anything from like the model itself that could be, we don't know the data that it was trained on. It could be malicious payloads. There's like a bunch of like tensor related issues in the way that the data gets serialized and unserialized. So this is like very ML opsy kind of part. And then you can shift that completely towards developers and come up with like LLMs generating secure code, or you just use the LLM as part of your, logic, and you prompt it and you use that prompt, and now suddenly you understand that you shouldn't trust the LLM because you get issues like prompt injection all over the place. So I think there's I think there's a growing kind of understanding that trusting LLM is still very difficult, not just the data like authenticity and stuff like that, but also just that they may be steered in different ways depending on the way that people prompt them. And there's like so many different, like I'm reading so many benchmarks and stuff around this. So sadly, like we're not at that point where you can blindly trust LLMs to generate code or do something good with the data. You have to like put guardrails in place.
Mm-hmm. Yeah. And we had this problem when I was working with someone where they wanted to use LLM as like the font of truth, like asking it questions, and it would be, it's like, well,
yeah,
if we get like a complaint like from a user and they say, why did you make this suggestion? We can't point at anything. Like it's completely black box.
yeah, it's a black
us.
box. Yeah.
We don't know why it did a thing.
Yeah, so traceability is a big factor. That's a problem. I think that's potentially more around the ethics and like understanding like why a decision got made so you could trace it back and understand. But I think at that point we're even not there. And there's definitely been some like papers around whether we can attest to what exactly made like the path that the LLM took to, get that decision. But honestly, even if we get to that point, let's say you get to the point of saying the model weights were this and that, and the layer out of like a billion of them is that which made it take the turn. What would you do? Would you like retrain the model? Would you fine tune on top of it? It's like even at that point, like if you could explain it, potentially you're at a different spot entirely in time. So I think there's like an ethics part to it. So I'm not entirely sure that's like part of the way that we want to trace and then fix afterwards and so on.
Right.
One of the takeaways I think for me here is like treat LLM as user input. So like you can't trust it.
100%.
Right? And then the other thing, and this is more generally for LLM usage, but I think applies here, is rather than asking the LLM or AI to write the code, you could use it as more of as a learning, like a coach, basically, to review code. So like you write the code and then you say, do you notice any security gaps here? And like using the prompts to like improve your security posture versus relying on the LLM to do the security for you, which I think is really the mistake. I was curious if you've seen or if you've done any tests or played with LLMs in that way as like a security reviewer for code that you're writing and what you've seen.
Yeah, I have something to cite on that, but I'm actually curious, Cameron. So what's been your experience with that one? Have you seen them being successful at like finding vulnerabilities, like insecure, but also like if you prompt them to fix it, do they fix it in a good way?
So I think in my personal experience, I don't know if I've ever asked it to review my code for security vulnerabilities.
There we go. You see, you don't think about it.
That's the problem, right? Yep. Yeah, exactly. And then I try not to rely on having like Copilot fix stuff for me, but I will have it introspect some of my code sometimes. So I'll go back and forth with it for like ideating on like a data model and stuff. But right now I don't necessarily use it to review code. And part of that is because I don't have the infrastructure in place for it to do it properly. Because long story short, I use old tools with like .NET Framework that aren't compatible with GitHub Copilot review. So I can't like run them in a container and stuff, which is what you need in order to like add GitHub Copilot as a reviewer. And maybe I could use Claude Code. Like that would be the only option, but I haven't signed up or anything to try Claude or anything.
So I will send you this other paper to put in the show notes, but basically there's a paper from February 2025, which means it's less than even 6 months at this point, less than half a year old. And what it did is it experimented with LLMs, finding vulnerabilities and also fixing them for JavaScript and Python code. This is what they did. And so I'll TLDR the results of that. 733 snippets is what they analyzed, out of which 1 of every 4 lines of JavaScript code was found to be vulnerable when LLMs implemented the functionality. To different, I think it was like over 40 different kind of CWEs, which basically mean different kind of vulnerabilities. So like insecure randomness and stuff like that, uses a insecure algo or whatever, cross-site scripting, those kind of things. And like when I mention that, people automatically like ask me, like their immediate next question is, okay, ask the LLM to fix it, which is like, yeah, of course, that's a very genius thought. That's exactly what those researchers did in that paper. They went on and said, okay, you found a vulnerability here. Now go and fix it. And they did that in two ways. One is they didn't give it any other context. It's like, okay, you found an XSS, go fix it. And the success rate of that is like, I don't know, like a 20% or something, like 10 point something. So it doesn't always, like the fix isn't guaranteed. And they show like different funny parts. They show like diffs in that research paper. It's like pretty interesting. So in one of them, you see the functionality. In the other one, the fix is like removing the functionality. So it like broke your entire thing while also fixing it, which is amazing. But yeah, not really helpful.
It can't be vulnerable if you don't have code.
Yep.
Amazing. I like that. Yes. So that's one thing. And the other case was like, if you feed the LLM with the findings from like the SAST tool and ask it to fix it. SAST is like, it's an acronym for static application security testing. So it's the tools that find vulnerabilities in your code versus then your dependencies, which is someone else's lines of code. In some cases, it's maybe the maintainers of Excalibur and stuff like that. So you understand this is dependencies versus your own code. And so even if they do that, the LLMs get it right about 50% of the time. So that's where we're at that paper, February 2025. I haven't read anything newer on that condition, but that's where we're at.
Yeah, so definitely what I'm hearing here is like, especially in JavaScript and Python, humans need to be part of the security story.
Mm-hmm.
You know, and
yeah, 100%.
TypeScript is not the silver bullet to prevent security issues.
Yeah, we're now back into TypeScript. Yeah, so definitely we're back there, closing the circle.
Actually, this is a fantastic, I think, close to the episode because I feel like the listeners right now are like, oh, we're all doomed. Like, there's just so much. First of all, there's so much in the web security sphere that you would have to know. And I know quite a bit about web application security, but still there's just stuff I don't know. And then hearing that, well, I can't even rely on LLMs, and in fact, they could even just be worse. It's like, we're all doomed. So what are your takeaways for the listener? Where can they go to like learn more about JavaScript and TypeScript and web security? And like, how should they handle this moving forward now that they are aware that they should be thinking about this?
Yeah, all right. My positive thoughts are that, everything is fixable. If you like adopt a mindset of like kind of like a QA person in today's like very critical mindset of, what is this, what is going on, why did the LLM, propose what it did, and so on. I think that's a good first start. Like you're aware, you're asking the right questions, especially if your mind takes you towards security parts. That's for awareness. I think we're at a good part. My second, like more practical takeaway is, if you feel like you want to dive deeper into security and you kind of like want to immerse yourself a little bit more in this, like, be a hacker for a day and stuff like that, I think, Conrad, this is maybe what you alluded to before with like, there are these kind of like capture the flag kind of competitions, but you don't even have to like feel very overwhelmed with that. There's like companies like Hack the Box and Try Hack Me. You could like Google them and they have like these challenges that you could take. There's a bunch of like really good material supporting that. So like you could take like think of it as like an escape room where you have like a challenge to fix. But in this case, you're trying to like hack the room in a sense.
Nice.
Yeah, so those are fun and nice. Sneak has, if you go to like learn.sneak.io, we have like an open, like free, it's completely free. You don't have to like pay anything or something, like an education platform. So we worked really hard on building snippets. So we know like developers have like a short kind of like, attention span. You can like want to just get like the bite-sized detail of like, yeah, just tell me what is prototype pollution. I don't want to read a book about this. So they're like really short. They're also interactive. You have like a prompt thing or something to interact with. And you can like finish one in like, 10 minutes or something. There's like a bunch of topics into cryptography if you like those, math riddles and stuff. So I feel the web is very immersed with content. It's just like finding the right one that resonates the most with you, whether you like to listen to like learn based on listening to podcasts or a website or something else.
TypeScript FM is sponsored by Excalibur.js, the friendly TypeScript game engine for the web. Like many of you, I got into computers because I loved video games and dreamed of making one, but game development always felt a bit intimidating. Instead, I built a career in web development, though that dream of making games never really went away. Then I met Eric, who showed me I could use my HTML, CSS, and JavaScript skills to create games with just a bit of game design knowledge and the right engine. Excalibur.js makes game development approachable, offering everything you need to build 2D web games.
arcade physics, sprites, animations, input support, and integrations with tools like Tiled and Ace Sprite. It's beginner-friendly, yet flexible enough to grow with you. Our team has published 10 games using Excalibur, all written in TypeScript. If you're a web developer looking to dip your toes into game dev or sharpen your TypeScript skills, give Excalibur.js a try at excalibur.js.com. Click the big tutorial button to start building your first game, Excalibur, a Flappy Bird clone. After that, join our friendly Discord community of web developers who love to help each other and share game dev tips.
We noticed that you enjoy game development, and
Yes.
you've also used it as a way to teach security. So we're just curious, like, how have you used game dev as a way to teach developers about security, or learned it yourself?
Yes, I love we're talking about games. This is like a whole fun part now. Why security? Go games. Yeah, so I was thinking of like some ways in making, security education a bit more fun at Snake. And so I was thinking maybe we create a game. Like that's fun way to like do stuff. And I was like, maybe like some Zelda stuff, some kind of like things like that. But like also creating, you create games, so like this is like such an overwhelming project to take. This is like it's not even just I really feel it's not even like the game mechanics or like the libraries, the physics, because that kind of exists. It's more like the storytelling. Like how do you make it fun? How do you put like the right rules and the right world that you need to create and not so I don't know, like I literally know barely anything on this. I went on to this thing. I was looking for some frameworks back then. I think one was like Phaser, but it felt outdated and not like, I don't know, it felt like not as right as I wanted to pick. And I found something else, like actually very quickly. I found someone called Anya, I think, on YouTube, and she does a bunch of game dev stuff, or she did a while back. And she has this framework called Kaboom. So I used that one. It was super easy to get going. Even pre-LLM days, I could get, a game generated pretty easily. There's like a lot of examples. So I went up and cooked this thing called Dependency Frost. So it's like it's such a fun game. It is a game where you like you're like the sneak logo is a dog. So you like patch the dog and it starts. So it's like a platform game. So you're like running, and then there comes up on the runway. There comes up like malicious packages like in an NPM package style, and you're not allowed to hit them. And as you move on, you pick on like different kind of like superpowers from Sneak and stuff like that. And then you get like bridges where you can, hop upon to like not hit those. And it's like such a silly game in terms of like my skills to build anything that looks nice. But we've put that into like events, and we put like a nice like a joystick that connects to the laptop. And people are like, yeah, I have to pass this. And like, they die after like a second. And they're like, no, I have to try again. And then they die after like 20 seconds and so on. It's such a fun game.
Yeah, I was playing it before this. It was a lot of fun. I love those runner games. So like, I'm like really into it. I like that kind of stuff. Like reminds me of, if anyone, is not familiar with like a runner game, if you've ever seen the Chrome, like dinosaur thing where you hit the space bar and you can play a little runner game while your internet's down.
Yes.
Yeah, that's an Easter egg. I don't know how many people know about that.
Because no one ever goes offline.
When you get the little dinosaur air in Chrome, you can play a game.
Yeah, switch off your internet and you can play that game.
There was actually 2 ideas I had for you for inspiration for if you're wondering how could I teach people about security. The 2 ideas that I thought about immediately were, one, I learned web application security from Troy Hunt, and he has a course called Hack Yourself First, where it's a course that walks you through how to attack yourself, and he uses a sandbox website, and you actually have to hack it to like continue learning and about stuff. Nice. But then the other example that I thought of, and I can't remember what the game was, but it's an actual game. I think you can get it on Steam, but you code in it, but the code that you write changes the game, and so you have to hack it in order to win. So you have to use real vulnerabilities to like continue. But I don't remember if that was in JavaScript or something else.
That is so good. I remember I have another version of that where I played, which is like it's like an 11 levels thing, and you get like you have to write code that there's like a puzzle thing, like a maze or something, like it's a different puzzle every time. Have to write the right code for the game to actually like get solved for like the it's I will send it to you afterwards. I'll find it. It's such a fun game to do.
But that could be a great way because JavaScript is a dynamic language. You could actually use it to your advantage where people can actually hack the game code using real vulnerabilities to teach them about those vulnerabilities. So we've been talking about HTTP parameter pollution, prototype pollution. What if you could actually do those attacks on yourself to succeed in the game, you know? And that's the way to learn.
Let me throw a little cross-site scripting in here.
Yep.
That'd be awesome.
I need to try a new game library as well. So now I have an excuse to try this out, this new thing you're working on. Or
I have one in mind.
Drop it so I can go try it.
All right. Excalibur.js. I'm not supposed to whisper in the microphone anymore. Excalibur.js. It's the one that we build.
That's the sponsor for the podcast, for sure. Thank you so much. Where can people go to learn more about you and and follow you and look at what you're doing?
I guess you could just Google Liran Tal. I hope it will come up first. I'm on X, on Blue Sky. I share a lot of content around like security and LLMs and AI and MCP and all this stuff is like super fun to just dive into. I'm on GitHub as well. I have a bunch of like projects we're speaking right after my date. 2 days into an NPM security incident, supply chain security incident with like ESLint config prettier. So I've built this tool called NPQ like 6 years ago. It's still like ongoing. And the idea is to give you proactive security so you do not get hit by this kind of malware. It's open source. So like I'm openly asking you or like welcoming anyone who listens to like if you want to like build on that with me and stuff like that. So yeah, I'm like very, I guess, accessible. Just reach out. I'm happy to help on anything you want to.
Perfect. And we'll definitely include all those links in the show notes.
Awesome.
That's good.
I really appreciate it. I have things now that I'm going to be doing different.
Amazing.
Yeah, I think this is going to be really valuable for the audience, and there's a lot of great takeaways here.
Yeah, me too. Me included. I'm going to go look at Excalibur next.
Awesome. Thanks for joining us today. We really appreciated it.
My pleasure. Thank you.
Thank you so much.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at Kamranicus.com and Eric is at ericonerheim.com. You can also follow the show directly at typescript.fm.